So hello everybody, and welcome to NASA Langley's Journey to Mars Teacher Discussion Panel. My name is Marile Colon Robles, or Marile, and I'm an education specialist here at NASA Langley Research Center. I have with me three wonderful teachers to give you more hints and ideas on how to implement the Journey to Mars activities in your classroom. Let's meet them.
Hi, my name is Marjorie Thrash, and I'm a 6th grade science teacher in Williamsburg, Virginia. I've been teaching for 16 years, and I worked on the badge this summer.
I'm Karen Kingery. This is my 31st year of teaching. I'm currently the STEM director, and I teach tech and engineering to 6th grade at Immaculata Catholic School in Durham, North Carolina.
My name is Kevin Hubel. I've been a science teacher for 26 years, and I'm currently an instructional STEM coach for the City of Newport News.
So Marjorie, you were part of the team that wrote this Journey to Mars badge. I wanted to ask you, what were one of the things that really excited you as a science teacher in using this activity?
I really enjoyed developing an activity that was focused on design challenge and giving kids an opportunity to be creative and problem solve. And at the same time, build upon it and integrate measurement and other science process skills in there, just kind of boost it up and make it a little bit more and offer that engagement piece to kids as well.
Okay, so introduce different variables into the engineering design process. Okay, great. Karen, we know that you've been doing this activity for a number of years in different ways. Can you share a little bit about what are the strong suits of this activity?
Well, I've used this activity with 3rd graders and 6th graders and 7th and 8th graders, so it really works well with all grade levels. What's interesting to see is that they really very much have a lot of the same ideas. The skills that you see, the ideas that you see are about the same for 3rd graders and 8th graders. Manipulating the materials are a little bit different, but they all seem to enjoy it. It gets them excited in space. I like to use the 7 Minutes of Terror video along with it, but it's been something that's been very successful with all grade levels.
Oh, that's great. One of the things that we've noticed in the team with doing this activity is that it gives an opportunity for all students, particularly those that maybe don't do very well with tests, those that are really like to play with their hands and build things, the opportunity of having a success, right? But introducing an engineering design challenge in a classroom can be a little bit concerning for some teachers. Marjorie, do you have any suggestions on how to do an engineering design challenge in the classroom?
Yes, I think explicitly going over the directions with students and not necessarily showing them a model beforehand, let their minds work and become creative, showing them the materials in advance of what's going to be available to them and make that limited number of materials available to them. And just going over guidelines, this is how we use, a styrofoam cup, we don't do this with it, and that sort of thing, and the kids kind of giggle, but then you eliminate any discipline issues you might have. But for the most part, kids are engaged and they're excited about taking their ideas and actually making something of it.
Do you have any ideas? You were talking about you've done it with different grade levels. So what are some things that you implemented differently between the 3rd graders and, let's say, the 8th graders?
With the younger ones, I didn't limit materials as much so that you would get a little bit more creativity. So they had a wider range. I didn't give them a bag that said, these are the materials that you have to use. They were out on the table and they could pick from the different materials there. So it kind of gave them a little bit more freedom to try some different things. Again, I didn't show them a model, but I did show them some parachute systems to start with. So we looked at some of the different types of parachutes out there. We looked at the Apollo parachute system, and so that they kind of had some ideas about parachutes. And we also did a little bit with wadding up a ball of paper and dropping a flat piece of paper, because the 3rd graders didn't really know that much about air resistance. So talked about what was it that you think that made one fall slower than the others. With the older kids, I've done it a couple of ways. They do have the limited amount of materials, and I've also done it with a challenge as a budget. So they had a budget to start with, and each thing cost something. And then they had to see if they had to try to make a successful device, but then also try to keep it within a budget. So they challenged themselves to get the lowest budget that they could. So there's a lot of different ways. And you can do different materials. That's one of the things that I liked about it was, you know, try anything you've got really will pretty much work for materials.
Yeah, and that's really exciting. It's important to point out that we have a suggested list of materials, and like with everything, you don't have to try and use everything. It's just a recommended list. And there's no one right way of using the materials that you're given. And can you explain to us a little bit how the city did it, particularly how much time did the students have maybe in the classroom or after school to participate of the project?
Well, what happened was it was given as a grade level, 6th and 7th grade level challenge to all the schools in Newport News. And you broke it up into groups of 2 or 3, usually there's 2. Then the kids would, you know, create their own capsule. They would go through the design process, and they would, you know, do their trials and collect their data. And based on who followed engineering design the best, engineering process the best, we used a rubric. And so that's how we grade students, based on the rubric, which is based on the design challenge, not necessarily just the outcome, but how well they followed design, the sketching, the building, the gathering of the data, and analyzing the data, and how well they worked together was a very important part. The better they did those things, the better their grade was on the rubric. And then each school had a winner for 6th grade or 7th grade. So you could send 2 teams to a citywide challenge. They would go through the same process, learning from their design, and they now redesigned, which was the second part of the badge, and they knew what didn't work before and redesigned to what did work in the present time. And so it was impressive. It really was. It was a neat activity, and it was great to see kids engaged in science, and especially space.
Those are great. Thank you for sharing that. Karen, you've used this activity in different grade levels. What was your time constraint? And did you do it in just one class session?
I went into one 3rd grade class with another teacher, which was children that really hadn't had much cooperative learning, so it was interesting. And we did it in that class within about probably a 45-minute. Now that was without any data collection. She did that, so I'm not really sure, you know, as far as a write-up and a rubric and so forth. Usually with my older kids, following the engineering design process, we'll spend for part of the day designing, and we have used Tinkercad I haven't on this one, but we have used some of the online design programs, and then they'll do the building and testing, and then the paperwork. So sometimes it can take 2 class periods. I always try to do with all of our STEM projects, we have a rubric that follows the process. And then we have a self-assessment, so they assess themselves and how they worked as a team member. And then we always have a team assessment as well, so that they assess the team. And most of the time I try to have some sort of individual, so they get that, and all of that adds together for a grade. So they may write up a short paragraph about their experience or about the science behind it or whatever. But that's one of the different ways. And the time, it can be a very short. It really doesn't have to take, you know, I know a lot of elementary teachers are really tight on time. That's something they always talk about as a problem. And it's easily done within a 30, 45-minute class period. Or you can stretch it out longer with the middle schoolers.
Yeah, I guess as long as you use the videos or anything to give them that pre-knowledge that they need before they go into the process, you can really shorten it up. We've done it many times in classrooms with just 27 minutes with the older kids, and letting them know ahead of time that they only have, let's say, 5 minutes for drawing, It's really important for them to have their first design and then maybe 7 minutes of building terror is what I like to say, and so on and so forth. So if you introduce beforehand how much time you're going to allot them per step, you could do it within 30 minutes. So very interesting. Marjorie, where in the curriculum would you see an activity like this one best fit?
Space is perfect. We teach 6th grade science space. That's huge. Also history, landing on the moon and how that took us to Mars and what that would mean historically. Explorers. It connects into a lot of history. I also think that it would be interesting to see if you challenge the students to extend it a little bit further and explore Venus. Say, okay, now what if we wanted to land on Venus? Let's talk about the atmosphere on Venus. How would that change our design? What kinds of things would you need to consider? The materials, would you need this elaborate parachute, and that sort of thing. Get them thinking.
Yeah, I like that a lot because now you can talk about atmospheres and the Earth's atmosphere and how understanding Earth's atmosphere, you can study different atmospheres from different planets. So I like that a lot. Any other ideas?
Well, being 8th grade physical science, and I love that idea because you can talk about air resistance, air resistance on Earth versus the vacuum in space as it travels through space, and then what kind of atmosphere do you have on Mars, the gravitational pull being less on Mars than it is on Earth. Newton's laws of motion, you just get the fluid friction. I mean, it just reeks with physical science. So, yeah, it was one of my favorites because I love physical science. So.
Oh, that's great. Karen, I know that your school is trying to be a STEM school, correct? How is an activity like this one going to help you and your school maybe become a STEM school? What are some of the ideas that you and the other teachers are trying to work together to become a STEM school and using the NASA context for that?
Well, actually, this year we've kind of centered a lot of our curriculum on Mars. And so we use it kind of across the board with different things. This activity that we're doing here is actually going to be done by our math teacher next week, I think. She's doing it, and she uses it with some kind of equations and so forth. But we're going to do some reading of articles. The 8th graders are reading The Martian. And so we're going to do some things with that. And then we have a big project at the end of the year that's on Mars. So really we have used a lot of, every subject area has some sort of NASA component to it. We're going to be using the images and looking at Mars images compared to Earth images and in the science classes. And they're doing articles in language arts and social studies. They're going to do a little bit about the history and use some of the history. In tech and engineering, we'll do things like this. So I've done the robotic arms with them, and so building the hab is our big STEM project at the end of the year. We're going to build a big walk-through hab. So so we're pretty much doing a lot, and there's so many resources out there. So I told them the tough thing is trying to find your way through the resources because there really is so many. So we're all kind of have a resource place that we're plugging in at the site so that we can put the resources in there, but doing a lot of things. And we did last year as well. But there's just so much out there to use.
That's really good. And the idea that you can integrate it in different classes, not just the science class or maybe the technical class, but you can really incorporate so many different things, language arts, math, technology, science, things like that into it is really powerful. Kevin, you mentioned about talking about Viking, and this is really one of the biggest successes for NASA Langley because the engineers that were responsible for that were right here in NASA Langley. So having that historical perspective is so important for us, correct? And
yes,
students.
Yes, it is. I mean, it's extremely important. You really want to know where you started and how you got to where you are now. I mean, that's incredibly important. Yes, I mean, there's not enough to see. You can't say enough about the Viking mission, the Viking program. It was incredible, especially in that day and age. So
Yeah, and I know that the team here worked very hard in having the students become the engineers, kind of like how the Viking engineers, nobody had done it before them, and they were trying to discover how is it going to work. We really want this activity to reflect on the newest mission, will be the Mars 2020 rover, and having them really feel like the engineers. They have to decide, how am I going to land this safely on Mars? In the engineering design process, one of the most important things is the design, the first drawing of the design process. Marjorie, do you have any suggestions of making sure that that step is accomplished? Sometimes we kind of rush through that step. So do you have any suggestions?
Sometimes it helps to have, if you have your students in a collaborative group, to have those materials sitting on their table and just they can look at them and kind of think about how they might use them, and then sketching that. And so maybe using that design, that initial design, as a ticket to start the activity so they can get their own materials and begin constructing.
Okay, so they have a place where they just see general, but they kind of touch.
Right.
Right, okay. Sometimes I recommend not giving them the scissors or tape or anything like that, because our instinct is really to start building, right? But we need that drawing component first, and it's particularly for the redesign, because not always when we fix it does it actually work. So we really need to make sure to have notes on what did we do to be able to kind of retrace our steps. Karen, do you have any suggestions about that portion of making sure the students draw their designs before they build?
Yeah, first, I mean, we've taught them what design is. They've learned to use the Tinkercad. They've learned how to use the graph paper. We've showed them different schematics and designs. But a part of every one of our projects is they have an initial design and a final design, and it's all a part of the grade. So that'll be on the rubric that they have those different things. And so that's always a part of it. And we always assign jobs. And in the beginning, especially with the younger ones in the 6th grade, you know, this past summer, all of our teachers got together and we came up with 8 jobs that we could use depending upon what the project is and a definition of what the job is. So we pick out the 4 jobs, or when they start getting better at it, they decide what jobs they need for the project. And so you've got a child that's an architect, and so it is their part of the project to do that. And so we talk a whole lot about, you know, everybody has their job. We talk about NASA and how important all these pieces fit together to make the whole. So it's very important. And I think when you assign it a job, that's an actual task that you need to do. And we do also have them, they have to show it, or that we have to see it before they can begin. But yeah, it's very important, and it is something, you're right, that they don't want to do. They want to just jump in there, but they learn over time. And now, originally, they'll just flop that paper over and start drawing, or if it's use a computer to do it. So,
well, that's very encouraging.
Yeah,
Karen.
it does. It takes time, but
yeah. And Kevin, can you speak about the importance of engineering design challenges in the classroom? Do you see any changes in the students and how they learn?
When the students become a problem solver and makes the project their own, they invest their time into something that becomes theirs. They want to come to school. They don't want to come to school for you just to tell them and fill them full of information and never get to apply, and they would never, they'd never truly learn it and put it into that long-term memory. So if they can come to school, take information, apply to a hands-on activity or an activity they can make their own, and then go home and tell their parents or whoever's at home, this is what we did because I learned this, then you've achieved your goal. Once they've applied it, they've made a product, they've tested that product, they make a product with revisions, you have a little scientist on your hand, and you've accomplished your goal.
When we've done it here at NASA Langley, the education team, we've noticed that, for the record, the best design that I've had has been from special ed 6th graders, actually your students, Marjorie. So we see a huge progress with the special needs students that we don't necessarily see with your top students, and that can be a little bit of a problematic, right? Your most talented students, the ones that are the that know how to take tests and things like that. How can you motivate those students in engineering design challenges when there's no one right answer, and that's really what they're seeking? Karen, do you have any suggestions?
And a lot of it is that they're so afraid to fail, and I think this is a safe zone, that failure is okay, and it's in that respect anyway. Because I noticed that those high achieving kids, that's been the hardest thing, because it doesn't work 90% of the time the first time they try it. So it really is it's just trying to create that safe environment that no one's going to judge you. And we talk about, different inventors and, scientists and what's been learned through failures and things like that. That's one of the things that we've done with them. And I think sometimes putting them in groups and they're not the leader, because they always want to be the leader, and taking them out of that leadership role. But that's always been the hardest thing with them, is that, I've even had tears with 6th graders and 7th graders over just it didn't work. Well, so let's do it again, and let's try something else. And then that it just comes with time. And now, I've been at the school I'm at now for 2 years, and we already see at the beginning of this year a big difference in them, a comfort level. And I think it's that creating that environment in your classroom.
Well, thank you so much. We hope that this discussion is very useful for you in the classroom. The list of materials is very simple and hopefully something that you can find in your classroom. And they are materials that engineers use. You won't start with your most expensive materials in your first trial. These are materials that our NASA engineers here at NASA Langley use. So please let us know about your ideas of implementation. We would love to hear more. Thank you.